I'll keep letting people in as they join. But Om, do you want to start sharing your screen and start the recording, and we can start with the webinar?
Yeah, Atul, everything has been started and yeah, I've shared my screen. Yeah.
Right. So, just to quickly introduce Om, he is heading the digital experience at a company called eMinds India. He has around 12 years of experience working in various front end technologies. He has essentially been working as a front end architect on Angular, then React, and a whole lot of the JS frameworks that have been coming up. He's also the founder of this platform. So it's not that this is like, I think, the second time he's taking a session, and we've done like 20-25 sessions, but we've been able to find his time this week to do a session. And he also runs a company called digitalspaceindia.com, which is again into IT and digital delivery. So, with that, Om, I'll hand it over to you to start the session.
Yeah. Thank you, Atul. I hope I'm audible.
Yes, Om, I can hear you. Yes.
Yeah. So, so I would just correct one statement that actually Atul, Ganesh, and me, we all three actually initiated this and kind of like whatever Atul explained about the platform. That is. Also, one more thing I would like to request to everyone that it's not that you have to be expert of any given topic, to share your knowledge or expertise with others. So I'm also little bit new to this whole test driven development, but still I chose to conduct a webinar. So that is something for everyone who thinks that I can only conduct a webinar if I'm expert in given topic. So that's the one request. So, okay, that's that. I'll start with the webinar. The reason I chose this test-driven development because I have been doing a hands-on development for more than 12 years now, and I mean I come from a generation, I would say, wherein BA was writing the requirement doc in isolation. Developer was coding the software in isolation, and then a testing person who would automate the test or do the functional test would be writing the functional test scenarios in isolation. So I kind of come from that era, I would say. But now, as we all see in especially I would say a product based company, the whole development strategy or process has changed. So that's the reason I chose this topic, so that we understand that what essentially has changed and how we can do this in our day-to-day project development, and even if we are not doing it, how we can adopt. So I would say that test-driven development is the best thing that has happened to software design. The reason, because I can see the benefit firsthand. That's the reason I would like to call that out. Uh, it is an iterative approach, I would say, just like we as a human being will evolve and adopt to anything which is happening around us, just like this pandemic. Like we all have evolved and adopted to this current pandemic situation. Similarly, the code does, right? The code will evolve and adopt itself to the test cases which are written. So that is a correlation, I would say, which I could draw before I move further. What we are going to discuss. So I don't want this to be a very one-way session. So I would request all of you to, participate equally in this discussion. So I would talk a bit about the definition of TDD, the history part, and what are the problems which a software development process has. What is the difference between if I do test first and if I do test last? What can be tested and what cannot be tested? What are the three laws of TDD cycle? Basically, around those, the whole this approach has been built. Uh, Types and advantages of test-driven development for developers and for business as well. How you can get started with TDD, uh, how you can apply that in legacy code, few tips which I have experienced during implementation of TDD, and few limitation which I have observed. Also, there is an interesting workshop. It's a very short one. I'll try to make it quick. Lego workshop. So about building a car. So that is also one interesting exercise we would be doing together. I hope everyone comes from a software development background, so this is not something new to us. We already know this cycle, the cycle of ideation to deployment. Uh, so, what essentially TDD does is it combines your implementation and testing part. So, that is what essentially it does in the whole life cycle. This is again extreme programming feedback loop. So I am sure we all are working in agile methodology, and we are aware of this feedback loop. I don't explain much about it, but I hope you understand that how we go from once we start coding any feature or functionality, and when it goes to the release plan, we are in a continuous feedback loop, I would say, or continuous iteration to deliver any of the given product. uh, this definition, I've taken it from Wikipedia, and there is a reason I chose this background, because TDD is a three-step process. Uh, so basically, what you do is first you fail the test case. So whatever test case you write, it's going to fail, meaning it's a red one, right? And then you would do some sort of coding or refactoring to pass the test case, and then eventually your test case will get passed. So basically, it's a repetition process wherein actually you turn a requirement, a given specification, into test cases, just like a BA would do while writing a requirement doc. He would be writing exception criteria. In a similar way, once you get any requirement from a product owner or a stakeholder, you would be writing all the exception criteria in form of test cases, and then you would write a code, or you would improve your code, or you would refactor your code to pass the test cases. So that is essentially the core definition of TDD is. I never knew that before I did this search, that this approach was discovered in 1950. And in 1998, this awesome guy called Ken Beck, and he rediscovered this principle. Actually, he don't call it that I invented it, because he believes that it's a part of extreme programming, and that's why he says that I've rediscovered this principle from the extreme programming. He coined this term in 2003, and this is a bit of history of how it started and how it got rediscovered, and the term itself got coined. These are few principle we all know about, and I don't want to read all those, but these are few principle based on which we build our software, and if we follow TDD, it will help support all this principle. So I don't want to spend much time here, but yes, you can go through it. Essentially, it's not only about building a working software. It's about designing in a way that it could be maintained, and you should be in a position to scale your software, and the code which you have written is going to be the modular, and that's the essential part of this principle is. What are the problems actually which we eventually face? Like at the moment, I lead a team of almost 50. In my previous role, also I was doing the same, and at most of the time, I saw that people were facing difficulty in testing code. Eventually, I mean, they were good at writing the code, but if you ask them to test their own code, they would face a lot of challenges. uh, at at many time what we do, we over engineer our solution, because actually we don't even, I would say, validate our solution, and hence we sometime end up over engineering sort of thing, and kind of we end up doing stuff which is not required at first place. This is very famous syndrome, I would say. While I'm working on this, basically kind of we keep neglecting the uh, testing part, I would say. And then at same time, once we deliver any code, and once the functionality is working, there is always a fear of refactoring the code, because we don't want to break anything which is already running, right? So that is a fear which we all have as a developer. Can I request anyone to share any of the problem which they face in a day-to-day life while doing the software development?
Yeah, this is Ganesh.
Yeah, yeah,
So generally, when we do a development, most of the time what we do is just write a code and pause it as a developer. That's what at least what our aim is. Let's at least get the positive part running, and then if we get time in the middle of rush of doing a release, we sometimes miss the negative corner cases. And I kind of agree with you what you are saying. In a test driven development, we should be doing in parallel testing when we are developing. So yeah, that's the one common problem I generally face when I'm doing a development.
right, right. I agree completely. We are in a hurry of doing the development, and then later we think of all the edge cases or boundary scenarios. Agree on that. Anybody else has anything to share on this? Okay, okay, that's okay. I'll move forward. So I've taken two quotes from again Kent Beck, and the one which I love is actually, if you cannot write a test for what you are about to code, then you should not even thinking about coding. So, and this is something, one of the favorite quote I've come across, that uh, you should first aim to write a test, and then you should think of. So essentially what we are saying is, first figure out what you want to do, and then you figure out how you want to do it. So it's like that, right? So once you write a test cases, once you write the test scenarios, once you enumerate all the test cases, then you are figuring out what you want to do, and then when you write the code around it, then you will figure out how you want to do it. So that is one part I wanted to talk about. So Ganesh, the one you explained, that wherein actually we do a development and then we go back and do the testing. So this is the difference when we do the test first and when we do the test last. So essentially, what we have to do when we are following TDD is, first we need to understand the requirement, and once we know that what exactly we want to achieve, and then we are going to add test case for each scenario, each given uh, I would say smallest nth level problem, and then we would write a code for that particular test, and we would run the test, and if it passed, awesome. If not, then we would rework and fix our code, and then we'll make sure that our all tests are passing. Usually, which I have seen, like in most of the company I have worked so far, kind of we understand the requirement, we implement the story, and then we kind of write test for story. That's what. So basically, we are not validating our test cases for the feature which is expected. We are trying to say that 2 plus 2 is equal to 4. So, and we are not sure even if that is what we wanted to achieve at first place. So basically, we write a code and then we write a test which is going to pass, because we know what code we have written. We'll take a function, we will mock the data which is required to execute the function, and then essentially we'll kind of do a fake call, and then we'll do the assertion part. But in that if you're not aware of what exactly you want to achieve, and if you're not taking care of all the features you wanted to achieve, then I would say your test coverage would not make more sense, because test coverage is against the code you have written. It's not coverage of the functionality or feature. So that is the main difference when it comes to a test driven development and the other way. Anybody has any question on this to approach?
Yeah, hi, Abdus here.
Yeah.
So my experience is yes. So on the first side, right, that writing the test cases first. As we know, we are all in agile, right? So what happens, before writing the test cases, we should know the requirement first, or story should be baseline, right?
Right,
But
right,
reality, that doesn't happen. Okay.
right. Okay.
So whether it is a matured multinational, or it is a growing, so irrespective of my experience,
Mm-hmm.
I see that it is the same story every year. Okay.
Right,
So I believe most of the cases, that is one of the major challenge we have faced. Okay.
right,
So as I believe Deepan also mentioned the similar. Okay. So I mean, how do we normally overcome that, right? Because
yeah,
and that
yeah.
is, I believe, one of the main challenge of TDD, right? Not documenting or not knowing the whole story at one glance, and that iterative process of writing the test cases keep going.
Right, right. So I agree with you, and honestly, I have also worked in a similar environment. And actually, the ideal scenario is when a product owner, a developer, and a person who is writing automation test cases, they work hand in hand, right? That's the ideal scenario wherein these people are working hand in hand, but in most of the cases they are working in silo, or they are in isolation mode, so kind of it becomes difficult. But again, when you write a code, right, you take some assumption, right? I mean, you cannot write a code until unless you don't know what you want to achieve, right? So I would say that in that case, whatever assumption you are making to write the code, for that you can write a test cases. I'm not saying that this is going to be the final test case. You will have to refactor once you discover the complete functionality or feature. But still, I would suggest that whatever assumption you are making to write the code, you should write the test cases first, and then you should write the code. And again, you will refactor it. So it's not going to be the final one. Does that make sense? Um am I audible, Atul?
Yes, so I can hear you. Yes.
Yeah. Okay. Okay. So yeah, I think I'll move forward. So let's talk about what can be tested in any given situation. I'm not talking about software only here. Let's think of building a car. Let's think of building any product, right? So valid inputs, right? So for example, if it's a petrol car, you cannot inject diesel inside it, right? So you have to make sure that you are injecting petrol in a petrol engine car, right? So you have to ensure, and you have to test that you are giving a valid input. Similarly, for any given function, you need to validate that you're passing the required parameter, and having required type as well, not just the number of parameter, but the type and other part as well. Invalid output, meaning if I accelerate, the car has to speed, right? So that is the expectation. But if I kind of accelerate, and if brakes are getting applied, then that is something not which is expected. Similarly, if I have written add function, in return I'm expecting addition, not a subtraction. So kind of so one is valid input and other is valid output. Now, invalid input is something when we don't pass required parameter, when we don't pass exact required type. I'm sure if you guys are used to of doing the object-oriented programming in Java or TypeScript or Python, you would make sure that you are not passing any invalid inputs. While writing any scenario, you would be taking care of errors, exception, and events. So similarly, it is applicable to any product you build. You have to test that what are the error scenarios, what are the exceptions, and what are the event which are getting triggered, and if it is performing the action which is expected. Few boundary conditions. So in case of API call, you would be testing the debounce part. You would be testing the API out of order response. So these are the few scenarios which I have covered, and I would say everything that could possibly break, we can test that scenario, we can test that feature. So this is what my understanding is, but I mean it's a very wide, but I mean just wanted to cover quickly what can be tested. These are the three laws of TDD cycle. So when you adopt to this TDD, first what you would do is you will write a failing test, meaning you have not written code, or maybe you have not written enough code. So first is this is our red signal, basically wherein it is going to fail the test, and then kind of write just enough code to pass the test. This is our green signal wherein actually we made sure to write enough code in and to pass the test. And again, refactor is something orange signal, I would say, wherein you would refactor your test if required, you would refactor your code if required, because it might be the case that the code which you wrote is not the optimum code, so you might need to refactor the code, and again you will validate if the test case are failing or it is passing. So I think this diagram make more sense. So the first block is similar to what we saw. It's kind of first you would write the test, this block, and then you would check if that whether the text fails, and if it does, you will write code, and then the test fails, and you will keep juggling between these three steps: write and rewrite the test, check whether the test fails, and write enough code so that it passes. Once the code is getting passed, then you come to the refactoring part, right? And here actually you check whether all the tests are getting succeeded. If not, then you come back to here, you correct your regression, you kind of update the test cases, you refactor the code, and if it's getting passed, then you again refactor some code. Again, depends, because there is always a scope of improvement, no matter how efficient code you write. So these are the cycles which we follow for the refactoring, and this is for the TDD. Anybody has any kind of question around this cycles, or any suggestion maybe based on your experience in while doing the development? Okay, no worries. I'll move forward. So what are the different types of testing? Maybe these are the one I know: static, unit, integration, and end-to-end. And the challenge is how do I choose between the static and unit and integration and A2A tests? So anybody here can help me understand that in what scenario I should choose to write a static test cases, in what scenario I should be writing unit or integration, and what is A2A?
Hi. So I think the unit test is written only when you have separate, like you have idea of separate units of your code, and then those separate units are testable in separation from others. So it's like the unit that you are testing, we are just testing that particular unit, and we assume that everything else is perfect or mock. So that you create an ideal situation, and then you put that unit, probably a class or a method or a function, to behave in a certain way. So
Right.
I think that's where you write unit test.
Mm-hmm.
Integration test is basically when you connect to other system. For example, it can be a database and or an API. Let's say that you want to test whether the system works, like the integration works. So, for example, if you are saving a value in database and then fetching that value, and then you test that whether the both values are same. You can even try to create a race condition and then decide that whether the that particular functionality is working with integration of other units. So you are not mocking those units.
Right.
So something like that. And end to end, I think it's more of a, like, for example, if you have created a web page or a website, and you are just you are automating the entire user flow. So you are logging the user, automatically clicking that button, and going to a web page, and then saying that, and then checking whether the screen has that particular input. And the end-to-end test can be triggering the units that we want to test. We have already tested, and then the integration, it basically tests everything. It's kind of a black box testing. So it's basically, you don't know about those units. You are just testing as if you are the user, or your test is a user.
Awesome.
Something like that.
Yeah, awesome, Abhi. I think essentially that what it means. So, I mean, this is a diagram of when to use what. So, I think you covered already all these three. I will just talk about the static part. So, basically, when you want to test the typos or any type errors, you can use linters or any code formatters, and that is where you can do your static testing. And rest, I think Abhishek explained very well in what case you have to write a unit test cases, in what case you have to write an integration one, and in what case you have to go for end to end. And more often you'd have heard this term called functional testing, which is referred as end to end. And I mean, I want this discussion to be a framework agnostic, so that's why I'm not referring to any of the framework, but yeah, there are a lot many frameworks in the market for different I would say programming language to do all four of this. Maybe we'll take another session wherein we'll deep dive into any of the given framework, but this session is more of a high level, I would say, which is a framework agnostic, just to understand the approach and concept. Thanks, Abhi. I think it really helps. And yes, let's move forward. So, wanted to understand that what are the advantages of TDD, right? So, again, I think I'll hide this slide. Anybody would like to mention if you're already using TDD in your current day-to-day job? Like, what do you think could be advantage when you do the TDD? Okay, I'll give some hint. I mean, everything.
Not 100%, but I believe some extent we are, we are following these TDD standards and framework. So, yeah. So what we mentioned, yes, totally, we are doing that or following that only. Okay, but yeah, not 100%, but some extent, maybe 70 to 75%.
But what is the advantage you get while using that?
Sorry.
What is the advantage? Do you see any difference of using this approach?
Yeah. So now the kind of project we're working, and if we see the holistic picture, right? So the end goal is, it will be, should be bottom up testing kind of. Okay. So once we are doing white box testing, and then we have to ensure all the business cases at the story level or epic level, those has to be passed, right?
Right.
So once we pass from the from the developer to say integration testing, or maybe from the developer to maybe QA, then QA to UAT, UAT to acceptance, all that, right? So
Right.
if we follow this, so I would say this is a bottom up approach, okay?
Right.
And more we are going to the close to the production, and that time it helps a lot in terms of there shouldn't be any instant surprise that okay, how come we missed these functionalities or these corner cases, right?
Right.
So it
Right.
helps in terms of testing time. But most of the cases, it is the development team who are writing and following this TDD. It is easy to identify all the corner cases or all the various business scenarios. Okay.
Awesome. Awesome.
So
Yeah.
yeah.
Right. Yeah. I think these are few benefits which a developer would get. Basically, you would be spending less time debugging, the code. You are confident about that you are going to meet the requirement because that's how you did the development. Uh, it kinds of build a safety net for you, and it eliminates a lot of bugs possibility, like you explained already. So these are few benefits I see for developers, and for business these are few benefit because the development cycle becomes shorter because you're doing the testing and development hand in hand. So that will reduce the software development cycle timeline. Uh, I would not say zero, but close to zero. I mean, 90% you can be assured that if you are having 100% coverage in terms of unit and integration testing, then you can be rest assured that you will have less defects. And this is very important thing. The test become an asset, right? Because the moment you write 100% coverage test cases for all the unit and integration part, kind of whenever you, let's say if you're a huge company, you're like 200 plus developers, so this will something act as a asset. Why? Because if somebody is joining new to your project or team and not aware of the end-to-end functionality, and let's say he wrote any given code, this test cases will ensure that he's not breaking any of the existing functionality, and this test case suite will help you identify even while compiling the code or maybe during the build check, before your code goes to production or even for QA. Tests are documentation, which is a very valid point. Basically, based on the, I would say, the requirement, you're going to write all the test scenarios, and then while for doing that, you will first enumerate your test cases, right? So that becomes kind of a documentation advantage. And I have seen personally the project I have worked so far, wherever I found that people had written very good test coverage, I think they were building very robust product, and I think they were having less time fixing bugs, production issues overnight. Usually, I mean, in software industry, we are very used to of this culture that we went home and then something broke, and then full night we are back to office fixing some production bugs. So the possibility of that will definitely reduce for the business. Uh, okay, let's get to the next step. When, let's say if all the advantages seems good to you and you want to get started, then what you should do? I would suggest that get some training. It could be a simple course from Udemy, or it could be, I mean, you can go to the any of the this framework which offer this TDD approach, and they have very detailed documentation. They have some playground wherein you can play with the code and you can understand. Shoot for 100% test coverage. This is very important. I mean, even you can choose a very small piece of code, maybe just one function, but make sure that the test coverage is 100%, so that you ensure that you are doing end-to-end validation. Don't expect to be perfect. Yeah, very true, because if you are a beginner and if you're getting started, I mean, you will learn, and it should be okay if you don't write a perfect one. And then once you follow above, then I think you will improve and then a kind of the results which you get. So I think you can use any framework. Again, I don't want to talk about the framework, but there are many frameworks who will generate a report for you, wherein actually you can measure the result and you can see the numbers, and that really matters, because then that will give you a confidence that okay, whatever I tested is working end to end, and it is covering up my functionality function end to end. Let's say there is a legacy code wherein you want to dive in, then what you should do, and these are the steps which you can follow. Go hunting, build your safety net. It is really important because you cannot touch everything, all piece of code. You have to decide which area you are going to touch, so that you are rest assured that what all you're going to affect. So you have to divide in bits and pieces. You have to pick up this small chunk, and then in incremental way you can speed up. So again, at the end of it, you can keep measuring the result. I worked on a project wherein the test coverage was almost 10%. People had literally written 2 plus 2 is equal to 4, and it took us like around a quarter time and the effort of almost 20 developers, but kind of we could achieve 90% coverage, and our production issues were literally almost minus 2x, I would say. I mean, it was when actually we joined that project, we used to get at least 20 bugs a day. Now it is 2 or 3. So that kind of advantage we got. These are few tips which I have. Maybe you guys can also suggest. I would say it's a skill. It's a coding mentality which you need to change. The approach you need to change, and it's the way of doing. So basically, if you come from a mindset wherein you want to first write a code, that mentality has to be changed, and after that it's a skill. So you will have to learn that it's not that day one you are going to write a test cases which will cover all the scenarios. Again, I would say that just do it. We keep delaying this in any given project. We think it's not important. We think we will do it after we deliver the functionality. We do it after the release. We'll do it after project or product is live. And I would say that don't do that. Don't delay that TDD thing. If you can do write your unit test cases. Insist on achieving 100% coverage. That is one important aspect. Again, measure, review, and make result visible, meaning you can also add it to your CI/CD pipeline, and anyone can look at your test coverage, right from your developer to business stakeholders or even higher management. These are the few limitations which I know, and you guys also know. It's a kind of hard to learn. It becomes difficult in some situation, some graphical user interface or some set of HTTP request or web services. In some cases, you really require to mock a huge object, and it's not always possible, feasible to mock that humongous object. So that there are like many challenges. I've listed few of them. Maybe you guys can go through it, and I mean, like everyone has their own experience while doing the TDD implementation. But even there are certain scenarios, like someone mentioned that like it's not always feasible to write a test case first. There could be a scenario wherein you cannot at all write the test case first, or maybe in some scenario you cannot even run your test case. So that is also a possibility. One more limitation is you would require developers or programmers with a high level of experience. Average developer might not be able to unit test the code end to end, and might not be comfortable writing the unit test cases or any kind of test cases. These are certain books which I would recommend. I mean, the one you can, this one is my favorite actually. I've started reading it actually, so I'm liking it. So maybe you can go for it. Based on which programming language you used for coding, you can choose a book accordingly. But it's good to read this once, and then you can choose any of the book based on you are a JavaScripter or a Python guy or a Java guy. So this is very interesting. I think this has nothing to do much with the software programming or development. Actually, this is something a Lego workshop. I just wanted to make it a bit interesting. So just thought of adding this, wherein you understand the approach. I mean, you can look for the syntax. You can look for the frameworks on Google. You would find it. I mean, that is not the hard problem to solve. The hard problem to solve is the design approach. I mean, how you would approach the problem, or how you would solve. So what we will do. I mean, ideally, it would have been awesome if we could do it live, but that's not a possible. So let's. So what we are going to do here is we are going to build a car. Okay, and to build that car, so the only challenge which we have is implementation change should not affect our test cases. Okay, and what you would be given is a bag of Legos, one highlighter, two type of grid paper. I'll explain why you need two types of grid paper, and a list of requirements. So you would know what is the requirement. You have a Lego using which you have to build a car. You have a highlighter to basically write your unit test cases on this grid paper. Okay, so these are the rules. Draw your test first. So first you have to draw the test. Okay, and then use the plate as a reference point. Add a few logos as possible to make your test pass, and make sure that the test would still passes before implementing the subsequent requirement. So basically you will do step by step. So this is the step one, or maybe I would say requirement one. Car must have a plate for the floor. So basically we are building a car using Lego, and you want to build a plate of a car, right? So this is the requirement. Large car has a requirement of 6 cross 8, small has a requirement of 4 cross 8. So what you would do, using the highlighter, you will fill the block based on the requirement. And then once you did that, you will put the Lego on top of this, and then you will kind of see if your test cases are passing or not. Similarly, in the software development, we do, right? First we write the unit test cases, then we kind of write the code. So here we'll put the Lego on top of this grid, and then we will run the test case to see if this test is getting passed or not. So this was one thing. Similarly, the second requirement is the body of the car must be one block higher. So then what you would do, again the requirement remains the same. To make it one block higher, you are at the next block. Again you would fill this grid with the highlighter based on the requirement and based on the size of the car. And again you would put the Legos, and you will see if the test case is getting passed or not. This becomes very interesting when you do it actually. Unfortunately we cannot do that, but I just tried to cover that. Then you want to have a steering wheel, so you will decide the position, and then you will again fill the color, and you will put the Lego on top of that, and you will again you will run the test and see if the test case is getting passed or not. Car must accommodate one driver, so you would again draw the blocks for the driver. You will again kind of do this unit, run the test and see if it pass in case of this second chart. Again car must have a windshield, so again you will draw that. So this is your windshield for this large and small, and then again you will see if this is getting passed. And then the car must have 4 wheels. You will again draw and run your test cases. And this is how you would build a car using Lego. So kind of what you did, first you took the requirement, okay, and then what you did essentially is you took a highlighter, you took a grid, and you kind of wrote all the test cases, and basically you highlighted those blocks which you want to fill with the Lego, and then kind of you had the Lego on top of that. So what you did is you first had the test cases. Sorry, you first had the requirement, then you had the test cases, then you actually did the implementation, and then you ran the test to see if the tests are passing or not. Let's say you did that, and I mean the customer is very happy with your car. You kind of obtain more budget, and there is some request to change or maybe to optimize or refactor. Okay, so what is the condition when you get some refactoring request, or if you want to do that? So what you have to do is you have to change the existing design, right? Because if you want to refactor your code, or if you want to change that something in the design of a car, then you will have to change your existing implementation, right? Now, to do that, you will have to also update your test cases. You cannot rely on your older test cases, because your older test cases were based on your earlier requirement, right? So you need to update your test cases as well. So let's say these are the two new requirements. Car must have a yellow decorative line on each side of the car. So now the car which we have built, we want to have a yellow decorative line on each door and front back. And we want to have a rear spoiler, right? So again, we would follow the same process. We would go and modify our sheet, right? The sheet which we had for the test cases. And then we'll again refactor, meaning we'll rearrange the Lego to achieve this, and then finally we'll have this final product which has all the yellow linings and the back spoiler, right? So basically what we did first, we did the MVP, but kind of we first wrote the test cases and then refactored our product and then delivered it. Again, there was a request in design change. Again, we refactored our test cases, we refactored our implementation, again we validated and we delivered our code, right? So basically what we learned here is what we learned from this TDD is refactoring. So basically we have to create an optimal test coverage, right? And which is going to increase our confidence in the code or even product which we are developing. Again, it will remove the fear of regression, because we are assured that the test case which we have written is aligned with the feature we want to build. We should aim for the validation per test, meaning ideally what we should do is we should pass one test at a time. The ideal way of doing this is not running all the tests at one time. You should write one test at a time and you should pass one scenario at a time. So let's say you wrote a function and it has 4 scenarios. So ideally you should write 4 scenarios in your test case and you should pass it one by one and kind of you validate that way. And this is very important. Test the state after execution, not the implementation, right? So I mean these are some kind of review which you should be mindful. If I wanted to make it a bit interesting, I know it was not because of this very online thing, but the whole idea is as a developer, as an engineer, I would say, I don't want to call it a developer because it's not just for the software development. As an engineer, if you want to build anything, first you should know what you want to build, okay, and then you should think of how you should build it, right? So I know it's really difficult and not always possible in the real scenario, but you should strive for getting the requirement in detail before you start writing a code or before you start building the product, so that there would be less refactoring, there would be less design change, there would be less test coverage. One thing I want to clear is writing unit test cases, writing integration test cases doesn't mean that you don't need a QA, you don't need a quality assurance. You do need that, right? Because when you write a unit test case or when you write an integration test case, you actually validate that on mock data, and mock data is not a real data, right? So when you're doing a testing, it's not a real data. So even in case of car, even if you can do the unit testing or integration testing, there has to be a real test once the whole unit is built, right? Similarly, in case of software, once the whole unit is built, you need to ensure that integration testing is happening. You need to ensure that the whole functionality, the user journey which you wanted to achieve at the end is getting achieved. And that's why you have a lot of framework which will actually eventually run a headless Chrome and evaluate or validate your functionality end to end. I mean, at each step you can validate, like you can use Cucumber to validate your requirement at first place, the one which is written by your BA, right? You can use, for example, in case of front end, like Jest or Jasmine to do the unit testing. You can again use Cypress, for example, to do the integration testing. I mean, for example, when you did the API call, what response you got, right? And after you got the response, once the component is getting rendered, whether it is reflecting the expected output or not. And then E2E is can be achieved by, let's say, for example, Selenium, wherein actually you write end-to-end script to validate your critical scenarios, your day one functionality, right? So these are the thoughts which I have related to TDD. I would kind of conclude my thoughts here that actually it helps you write quality code. It helps you ensure that you have built a product which has all the feature you wanted to build at first place. And again, it would help you, I would say, uh, have a cleaner design, because if you write a test case and then write a code, you would have a better clean design rather than if you first write a code and then write a test case. Because then, and I would say some people would say vice versa, again it is case to case. Maybe in the next session we would talk more about any given framework, or maybe we'll take Java or a front end like JavaScript, how actually you can do a unit testing integration and E2E. So that's what I would like to conclude here. Anybody has any question or any thought which they would like to share related to TDD?
Hi, I have a question. So my question is like I've heard about TTD and used it as well at in some project. So and it for me it looks a lot like the other framework known as BDD. So can you tell me what is the difference between them? Like when to use when or what?
You mean the BDD versus TDD, you're saying behavioral driven development and test driven
exactly.
development, right? So I would say when you're writing a object or a class, right, wherein you know basically wherein you know that this is exactly how it is going to act. In that case, I think TDD works because you know exactly how the implementation is going to be. But in case of, for example, I think mostly when it comes to front end, then I think this behavioral driven design or behavioral driven development comes, wherein actually you don't know complete scenario that how your component is going to, or how your component behavior is going to be based on different scenarios. For example, a click might work different in case of a mobile device, and it might work different in case of a desktop. So there could be a different kind of event listeners which you had to kind of validate. So this is my take. I'm not 100% sure, but usually you use BDD in case of a front end development mostly, and when case of Java, wherein actually you know that it's just in functionality which you're trying to achieve, then TDD helps. But mostly I've seen people use mix of both. I mean, like again, it's case to case. I would not trade off TDD for BDD, and I would not trade off vice versa. So these are my thoughts, Abhi.
Yeah. So so that's something that I'm asking just because one of our product manager actually mentions this, like either use BDD or TDD. I mean, you can use both of them together, write your cucumber behaviors and then write your test. But he was like, no, just use one of them. Don't use both. So that's I mean, he never clarifies why.
Okay,
So that's
okay.
that's why I was asking.
No, I would say TDD came first. I think it came in 90s, late 90s, and BDD is pretty new. So eventually, I would
Right,
say
right. So
BDD is a optimization on TDD. So probably whatever problem people were facing with TDD, they kind of tried to resolve that in BDD. That's what I've read on many places. This is my thought.
mhm.
Like, do you have any
So,
other? Yeah.
Abhishek, one view also from my end is like for BDD to work, essentially like the PO or the BA, right? They need to write those Jerkins test cases, right? I mean, essentially, if it is the same guy writing it, so if the developer writes it, then TDD, BDD, I mean, maybe the framework differs, but essentially it won't make much of a difference. It's more about if the PO can articulate clearly that these are the you know test cases to pass, right, behaviorally. That is when it then starts differentiating, at least from a usefulness perspective. Otherwise, not like just from a framework perspective. So I would say like if the PO is writing those Jerkins cases for you, uh, I feel like that's when that you kind of are drifting towards BDD than TDD.
Yeah, that makes sense. Thanks.
I think we should have one open discussion on TDD versus BDD to understand it better, maybe.
I think Vinod was about to contribute to the.
Yeah, I was about to say that TDD and BDD, we should not compare it much because TDD is like a development practice. We say that, okay, we are doing the development test driven. So, whereas BDD is one of the way to do the testing. So, BDD, you can do it before and after both. So, it is up to us when to implement it. But TDD builds a practice that, okay, we want to do it test driven. So everything will start from the day one before we start the development. So it starts everything in parallel. That's the approach. Any approach can be taken, whether it's a BDD or something else.
So you are saying that BDD is just an approach of achieving TDD?
Yeah, one of the methodology that we implement to do the testing.
Mm-hmm.
So for example, if I'm doing a microservices, I might go for something like a zero code for testing. So I'm not doing between zero code also there is a BDD. But if I'm not going for it, it doesn't mean that I'm not following TDD. So I can say that I'm doing the BDD, TDD test driven development. I'm configuring everything right in the beginning using zero code.
Oh, that makes sense. Thanks. That actually clarifies things.
Cool. Thanks.
Yeah. Anybody would like to add anything to TDD or BDD? Okay. Then I think we are good. Maybe Atul would have shared a link of feedback. Please help us with the feedback actually to understand what we can do better. And thank you all for joining. And yes, see you next weekend. Thank you.
Thanks.